In this concept, we're going to talk about inequalities in triangles. One thing to note is that the measure of an exterior angle of a triangle is always greater than the measure of each of the remote interior angles inside the triangle. Let's look at what this means. So this is the exterior angle, and we talked about this before in a prior concept. And these are the two remote interior angles. Okay, and typically, actually, the interior angle is equal to the sum. The exterior angle of the triangle is equal to the sum of the remote interior angles of the triangle. So typically, angle 3 is equal to angle 1 plus angle 2. Okay. But we can also obviously set an inequality, and we can say that because of this, so angle 3 is always going to be greater than. Okay, so this is angle, and this is the greater than sign, right? Greater than angle 1, and angle 3 will always be greater than angle 2, right? Here's another feature of inequalities in triangles. If two sides of a triangle are not congruent, then the larger angle lies opposite to the longer side. Okay, so here we have a right triangle as an example, and then we have sides, we can call this side A also, so side A, B, and C. Okay. If we choose any two sides, right, so here we're choosing sides B and C to compare, right? So side B is opposite to the 50-degree angle, and side C is opposite to the 90-degree angle. So obviously sides B and C are not congruent, right? I mean, since it's a right triangle, the hypotenuse is bigger than the other sides. But here, one additional reason why we can say that this side is bigger, besides knowing that it is a hypotenuse in a right triangle, one other reason is that this angle is 90 degrees, right? So since C is opposite to the larger angle, so 90 is obviously larger than 50, right? Therefore, side C is longer than side B. So again, because it is opposite, so the larger angle is always opposite to the longer side. Or you could say it vice versa. The longer side is opposite to the larger angle. Another feature of inequalities in triangles are side length inequalities. In any triangle, the sum of the lengths of any two sides of a triangle is always greater than the length of the third side. It has to be, okay, for you to get a triangle to begin with, right? So A plus B, here in this triangle, the sum of sides A and B has to be greater than side C, the length of side C, or segment C. The sum of segments A plus C has to be greater than the length of segment B. Sum of segments B plus C has to be greater than segment A. If any three side lengths do not satisfy the rules above, a triangle cannot be formed with the side lengths given. And why is that? So let's say we have a very long side of a triangle. Let's say we want to make this, like a very obtuse angle triangle like this, right? So just like this, right? So clearly this side, let's give these names. So A, B, and C, right? So side C is very long, but clearly if you drop this side down, right, and dropped this side down, B, and added them, they would be greater than C. They would add up to something greater than C. What about if you had two sides that were just the same length as C? So if I had this one side like this, right? This is a side, let's call this A. And then this is another side, let's call it B. If A and B added up to C, you couldn't have angles here, right? You couldn't like lift them up to make angles to make a triangle, right? The moment you lift this up to get any semblance of a triangle like this, for example, the moment you get any type of angle here, right, besides 180 obviously, or besides 0 here on these sides, then A plus B has to be greater than C. Okay, there's no way to even make a triangle with A plus B equaling C. Okay, this does not work. This does not give you a triangle. So if I gave you possible sides of a triangle at 2, 2, and 4 units, right, you have to choose you have to try all combinations of sides and make sure that any two sides add up to a number that is greater than the length of the third side, okay? Where in this case, these numbers do not do not fulfill that rule, because these two sides, 2 and 2, they add up to 4. So the condition fails for this set of side lengths. So these three sides cannot give you a triangle in any arrangement, in any configuration. Okay? So hopefully this explanation was clear. Let's look at some examples to solidify this. Is it possible to form a triangle with the given side lengths? 2, 2, 4. We just talked about this, right? Let's test the numbers. Add 2 and 2. So 2 plus 2 is 4. Since the sum of the lengths of the two sides is equal, not greater than the length of the third side, and those side lengths cannot form a triangle. Okay? The other side lengths should not even be tested, since one false test is enough to prove the three side lengths are invalid or do not form a triangle. Okay? 2, 3, and 4. So 2 plus 3 is 5. That works because it's greater than 4. So let's write them out here actually. 2 plus 3 is greater than 4, right? 2 plus 4 is greater than 3, because 2 plus 4 is 6, greater than 3. 3 plus 4 is greater than 2, because it's 7. Right? So 5, 6, 7. Right? 5 is greater than 4. 6 is greater than 3. 7 is greater than 2. So all of these do work. Therefore, these lengths can form a triangle. Okay? 1, 2, 3. So 1 plus 2 is equal to 3, right? Which makes these not able to form a triangle. Okay, these side lengths cannot form a triangle. 3, 4, and 5. 3 plus 4 is 7, which is greater than 5. 3 plus 5 is 8, which is greater than 4. 4 plus 5 is 9, which is greater than 3. So these can form a triangle. Okay? And here we have some exercises. Please pause the video, work on these, and come back for the solutions. Okay, in our first exercise, we need to order the triangle's side lengths from shortest to longest. So we have three sides, A, B, and C, right? A is opposite an angle of 75 degrees. B is opposite an angle of 35 degrees. And C is opposite an angle of 70 degrees. So again, from our rules of inequality, or feature inequalities in triangles, we did say that the longest side is opposite to the largest angle, and vice versa. The shortest side is opposite to the smallest angle. In which case, the angle arrangement would be 35, 70, and 75, right? In which case, our side arrangement from shortest to longest would be B, which is less than C, which is less than A. Okay, so this is our side arrangement. Okay. Second exercise, test whether the following side lengths can form a triangle or not. 1, 2, and 4. So we start just trying all the possible combinations. So 1 plus 2 is 3, which is not greater than 4. Okay? So this cannot form a triangle. Okay? 7, 7, and 13. So 7 plus 7 is 14, which is greater than 13. 7 plus 13 is 20, which is greater than 7. The other 7 plus 13 is also 20, which is greater than 7. So this fulfills all conditions, or this set of side lengths fulfills all conditions. Therefore, this set of side lengths can form a triangle. Okay. And lastly, we have 4, 4, and 4. Okay. This is actually an equilateral triangle, right? Which can be a triangle. So you could just, take the short end of it and just say, this is a possible triangle. Or we could just follow the same process, right? So just try the different combinations. 4 plus 4 is 8, which is greater than the remaining 4. Again, 4 plus 4 is 8, and 4 plus 4 is 8, right? So same thing. So all these conditions are valid. So this set of lengths can form a triangle. Okay? And this is it for this concept. See you in the next video.